So from the basic terms homework, we're looking at 3 and 4. We know that once we find the radius of a circle, that's the end. That is the radius. It is the radius throughout the whole circle. It cannot change. So everyone take a look at circle P. What is the radius of circle P? Well, it's 8. It's 8 all the time, every time throughout the whole picture. So if I find a new radius from the center to the circle, that's what a radius is. It's the distance from the center to the circle. PB is another radius. So now I know that PB is 8. Now let's look at circle Q. What's the radius of circle Q? Circle Q is 6. So this distance from here to here is 6. And we have some overlapping segments here, right? So to get that first one, to get VQ, we can just do a subtraction. We can just subtract those. 8 minus 6. Well, let me get back. Actually, we're going to do Pythagorean theorem, right? Because PEQ is a right angle. So we have this triangle right here. We have this triangle right here. This is 6. This is 8. And we know that PQ, we know that it's 10. Pythagorean theorem. So we're actually not subtracting. Sorry. So now we are going to do some subtracting. If the whole thing's 10 and we've used up 8, then this piece is 2. If the whole thing's 10 and we've used up 6, then this piece is 4. So that's where the 2 and the 4 came from. Number 7, explain why PEQ, so this triangle, is my picture getting messy enough for you yet, is congruent to PFQ. Now we could use the right angle, but I'm not even going to use it. This segment's 8, that means this one's 8. They're both a radius. This one's 6, that means this one's 6. They're both a radius. This is a shared side. So one of the reasons, you could have put side, angle, side, but another reason could be side, side, side. Okay, in number 16, we have circle S. So you should have drawn a picture. If you have your homework and you did not draw a picture and you got it wrong, that is probably why. Point Q lies inside circle S. In this section, it lied outside. This time it lies inside. So we want to know how many lines through Q contain a diameter of S. Okay, let's think about that. So we have to go through Q, and we have to contain a diameter. Now, by definition, a diameter always goes through the center of the circle. So we have to now go through Q, and now we know we have to go through S. Well, we learned a long time ago that through any 2 points, there's how many lines? 1. Through any 2 points, there exists one line. So that's why the answer is 1, because you can't draw another line through Q and S that's different from the one I already drew. Number 20, always, sometimes, or never. A line that passes through a point inside a circle is a secant for that circle. So we established the fact, so now we know from now on that when we're doing these problems, we're going to stay in 2D. We are going to stay coplanar. So we aren't going to discuss what Kendra was talking about, skew lines, where I have my circle and then I have a line piercing through it this way. We're not even going to go there because we're going to stay flat and we're going to stay 2D. So we are in flatland, guys. So if I'm in flatland and if I have a point inside my circle, let's call it A, point A, then if I'm a line, so I go on forever, and I pass through A, I have no choice but to be a secant. I am always a secant because I'm going to hit my circle twice, always, because A is inside my circle. If you got sometimes, I want you to draw me a picture. Because every time you write the word sometimes, that means you have a time when it did happen, and you have a time when it didn't happen. So if you want to write sometimes, you better be able to show me a time that it did and a time that it didn't. So show me when it didn't happen. What is that called, by the way? When you show a time that something didn't happen? A blank example? A counter example? Okay, 25. Let's pretend we know what this means when it's talking about a handle. I don't know. A handle is 0.41 centimeters in diameter. Is that some sort of construction term? I guess I should look it up. I don't know. But we know it's a circle because it has a diameter. So this handle, whatever this thing is reduced, so it's getting smaller, to a diameter of 0.34. Diameter of 0.34. Find the depth of the cut. So what that's asking for is this right here. That's x. So this is just a subtraction problem. You can subtract the diameters, but then you would have to divide by 2 because you'd have the left and the right. You only want to know the depth of the cut. Or you could find the radius of the first one, find the radius of the second one, and just subtract those. You know what I'm saying? So subtract the diameters and divide by 2. Or just subtract the 2 radii. Find them. Okay, number 6. Let's see. Find the width of the washer. Pretty sure this is the exact same thing. Yep. Yep, you're trying to find x. X is this right here. So subtract the radii or just subtract the diameter and divide by 2. Last one, number 27. You just need to draw many pictures, right? Well, not many pictures. It should only take a couple. Draw some circles intersecting. Try to make them intersect more than twice. Could you do it? Did you try every way you could think of? Okay, but if they're the same circle, then they're not intersecting. A circle can't intersect itself. If they're the same circle, then they're not intersecting at all. There's not 2 circles happening. There's 1 circle. Okay?